Hey guys, Beacon here. So there was this interesting question in yesterday's Codeforces round called dual. So here's the solution to that problem. So the problem goes, there are n numbers where n is less than or equal to 20 and the numbers are between -20 and 20. In one move, you can take any number and add it to any other number, including itself. So with these moves, the goal is to create a non-decreasing sequence. Like, the sequence must be sorted, and you have to do this in as few moves as possible. So there are two subtasks to this question. The first being you have to do this in at most 50 moves, and the second one being you have to do this in at most 31 moves. For the first version, what we can do is we can see that the numbers are, well, quite small. They're between -20 and 20. So what if we manage to make some large enough number and then we can pretend like the initial numbers are quite irrelevant? Well, that is what we're going to do. So consider there being at least one positive number. We can deal with the other case later. We can technically add it to itself 7 times. This will give us a number of at least 2 to the power of 7, which is 128, because if we start with at least 1 because it's a positive number, and we double it each time, so it's at least 2 to the power of 7. After we do this, we can add it to the first number to get a number that is, well, at least 100, because the first number could be, -20, which makes it 108. So at least 100 in the first position, and afterwards, we can just add the first number to the second number twice, and then add the second number to the third number twice, and so on. So we double each time. And since the first number was so large in the beginning, adding double that to the next number will guarantee that that number is bigger than the first one, and we can continue this process to make a increasing sequence. So what if it's all negative? So what if all the numbers are negative? Well, then we can just make a very small number, like -128, and then add it to the end, and just do the same thing backwards, like add the last number to the second last number twice, and add the second last number to the third number twice, and so on, and this creates an increasing sequence. So how many moves does it take? Well, we spend 7 to get the largest number, plus 1 to move it to the first, add it to the first, so that's 8 moves to get the first one large enough, and then we have 19 times 2 to sort out the other ones, which is 38, and 38 plus 8 equals 46, so that's below 50. So this solves the first subtask. But what about the second subtask? So first of all, realize that 31 moves for 20 numbers means that we have to try to fix or make 2 numbers increasing with 3 moves around that. So how can we achieve this? First of all, let's try to improve our algorithm from before. Consider the algorithm we did in the first version of the question. It's quite wasteful, because sometimes when the next number is non-negative, we don't have to add it twice. If there's 5 and then 2, we don't have to add 5 and 5 again to the next number. We just have to add 5, and it becomes 5, 7. So we could just save a move there. And the only problem that occurs is when the next number is negative, because then it isn't big enough. So consider 3 numbers, where the first number is A, the second number is -B. So first number is positive, the second number is negative, and the third number could be anything. So A, -B, and C. Now, consider this. We want to try to make this increasing, and we just define A to be positive. So we try to make -B and C increasing with 3 moves, as we said earlier. Make 2 numbers increasing in 3 moves. So consider this algorithm. We add the first number to the third number twice. So now it becomes A minus B and 2A plus C. And then we can add the third number to the second number. So it becomes now A, 2A plus C minus B, and 2A plus C. So let's try to see when this is increasing. Realize that if A is at least twice the absolute value of B and C, then A plus C minus B is not negative, because A is at least minus C and minus B. So plus C and minus B can't make A negative. It can't be smaller than A. So it can't be smaller than -A, I mean. So this means that because 2a plus c minus b is just a plus c minus b, and a plus c minus b is non-negative, it's bigger than a. And similarly, well, obviously, 2a plus c minus b is smaller than 2a plus c, because minus b is negative. So in this case, we have created we have created two numbers more that are increasing with 3 moves. So this is good. This is a good algorithm that could get us to the solution. So the only problem we have now is to try to create this number that is at least twice the absolute value of any other number, which is what we needed before. And we want to do that in as little moves as possible. So here's what we can do to create this large number. Consider the number with the largest absolute value. If that number is negative, then we can deal with that case later, so assume it's positive. Now, consider if the first number is positive. If it is, then we can just add the maximum absolute value we found earlier 2 times to that number, and that number is now bigger than or equal to twice the absolute value of any other number, because we just added the max absolute value twice. If it's negative, instead, we can actually just skip the first number. We don't have to care about it. We can just try to make the second number the starting number. So we can add the max absolute value to the second number 3 times. The first time we're making the second number positive, and the other 2 times we're making it twice the absolute value of any other number. So now the second number is twice the absolute value of any other number. After we've done this, well, in the first case, we've made the first number this big number in 2 operations, and we have 19 numbers left. And since we can make any 2 consecutive numbers increasing in 3 moves, we will use at most 2 plus 18 over 2 times 3, that is the 2 and 3, plus 2 for the 1 remaining equals 31. So 2 plus 9 times 3 is 27, plus 2, that's 31. And in the other case, we use 3 operations to make the first number is negative and the second number is a large positive integer. And then we have 18 numbers left. So 3 plus 18 over 2 is 9 times 3 is 27. So that leaves 30 moves. So both of these fit the second subtask solution. Now, what about the case where the largest absolute value is negative? We can repeat this process, but from right to left. And we make the last number, or the second last number, a very small negative number. This works because it's essentially doing the same thing. If you look at absolute values, we're making an increasing sequence from right to left. So that means that's a decreasing sequence. But actually, because we've made it negative, since these are all negative numbers, it actually flips to becoming an increasing sequence. So that's why the negative case is just the same thing as the positive case, which satisfies the question. So that is the solution. I hope you guys enjoyed this video, and thank you for watching this video.